I believe you had set it up for an hour lunch, which I'm fine with. We will take a break sort of halfway through the morning session, and we'll take a break halfway through the afternoon session. And then I like to leave the last 30 minutes of the day open for Q&A. If there's something that you wished I'd gone over that I hadn't, maybe, you know what, I could do this in Rockwell. How would I do that in Siemens? I want to make sure we leave plenty of time at the end of the day for you to ask questions. However, at any point today, feel free. I don't know if we're going to leave the mics unmuted or not, but certainly ask questions either with your local folks there or certainly you ask me. Um, if you have to listen to me talk all day, it's going to be boring for you and it's going to be boring for me. I love the challenge of questions. So please, please, please ask questions. And actually, I'm gonna ask questions for you throughout the day. So if we could leave the mics unmuted, that would be good.
Yeah, I will, Ron. But if it
Great.
if you get too much background noise or something, just let us know and we can mute.
Sure,
So
we'll do. Perfect.
okay.
All right, so what are we going to do today? So because we are virtual, we're not going to spend a whole lot of time with a hardware comparison. I have a slide or two that talks about the hardware. I think it is important for you to say, okay, well, I know that the control logics is sort of the flagship of Rockwell. What is the equivalent family on the Siemens side? So we'll go a little bit over that. But then we're going to mainly spend our time in the software. And we're going to compare Studio 5000 versus TI Portal. And we're going to do that by looking at a project that was developed in both Rockwell and Siemens. We're going to sort of tear it apart, look at the individual components and pieces and parts, and then we're going to add to it. So things like controller configuration and I/O configuration. In Rockwell, you address I/O with local :3:I.data.0, something like that. Well, how do we address I/O in Siemens? And in Rockwell, maybe you create an alias or maybe you buffer your I/O. How do I do that in Siemens? To me, the first building block of object-oriented programming is the user-defined type. How do we do that in Siemens? How does it compare to the way we do it in Studio 5000? When I create tags, I know in Rockwell I can put them in controller tags or I can put them in program scope tags. Do I have that same type of structure in Portal? And what are the tag naming rules? How many characters can my tag names be? And can I use special characters like a number sign or a percent sign? And then to me, the biggest, let's say the biggest difference between Rockwell and Siemens is how the projects are organized. We know in Rockwell we've got tasks, programs, and routines. How does that compare to organization blocks and function blocks, or do they compare? And then sort of finally the what I consider the second major building block of object-oriented programming is the add-on instruction or the AOI. Hopefully everybody in here is familiar with add-on instructions. AOIs, either you've created your own or you've had to troubleshoot one, or at least you're familiar with them. How do they compare to function blocks or functions inside of Siemens? We'll do a little bit with communications, factory talk links versus whatever Portal has to offer. Because we are virtual, we're going to be leaning real heavily on simulation. Rockwell has two different offerings there, Emulate and Factory Talk Echo. How do those compare to PLC Sim? Then we're going to get online with the simulator and do all those things that we love to do when we're online with a PLC. We're going to monitor tags and create watch tables and monitor logic and do searches and cross references and online edits. We'll do just a little bit of HMI development, not a whole lot there. You could spend a whole day just learning the HMI, so we're going to do just a little bit there. But then diagnostics. If a component of your control system fails, you lose communications to a rack, you lose communications to a VFD, how does the system let you know that there's a problem? How do you troubleshoot that problem? And if you want that problem to be alarmed up on an HMI, how do we do that? And how much work is it on our part? And then if we get there this afternoon, we'll talk a little bit about libraries. You've created this great add-on instruction. They're not called that. We'll get to that later. But you've created this great AOI. You want to share it with all your friends and neighbors. In Rockwell, we know we would do an export-import. Well, Siemens has something called libraries, and hopefully we can get to that this afternoon. All right, so the project that we're going to be looking at, I've actually got it running here. So here's our PLC simulator. This is free, by the way, comes with step 7 programming. And then I've also got my HMI simulation running, and it's just running in a web browser, in this case, Google Chrome. So what we have is we've got a mix tank. That mix tank has an agitator up top. It's a variable speed controlled by a VFD. I can click on it, bring up a faceplate. I can put it in manual. I can start it. I'll get running feedback. It turns green, lets me know that it's running. Put it back in auto. I've got 2 valves. I got a steam valve, SV11, and a discharge valve, SV12. On both of these, I can click them, bring up a faceplate, put it in manual. I can open it. It'll turn yellow, let me know that it's moving. It'll turn green, let me know that it's opened. And then the simulation is smart enough to say, oh, the steam valve's open. I need to start increasing the temperature. So we can see the temperature is starting to climb in the tank. Putting back in auto. And then each one of these devices have a faceplate. You can put them in manual, start and stop them, and open and close them. And you can take a copy of this project is on your desktop as an archive. We'll get to that in a second, but you can certainly take this project home with you. You can tear it apart, take a look at it, see what all the components look like, how it was made. That is free for you to take. But the main thing that we have here is a sequence. Right now, the sequence here is in step 1. It's an idle. Been there since I cranked it up earlier this morning. All the preconditions have been met for me to start the sequence, as shown here with the green start push button. So I'm going to click it, start the sequence. Go into step 2, which is manually add ingredient number 1. The operator opens the lid. He dumps in whatever ingredient number 1 is. We see a corresponding jump in the level transmitter. He closes the lid. He can now click the step button to advance the sequence. Step 3, same thing. He opens the lid. He dumps in whatever ingredient number 2 is, mystery ingredient number 2. We see a corresponding jump in the level transmitter. Closes the lid, and he can hit step. Step 4 is going to happen real fast. It's just going to enable the steam valve and the agitator, and then drop right into step 5. Steam valve's opening, agitator's running. We've gone into step 5. Operator again has opened the lid. He dumps in whatever ingredient number 3 is. Closes the lid. We see the jump in the level transmitter, and we hit step. So now we're agitating, we're heating, we're just waiting for the temperature to get above 90 degrees C, and we can see that the temperature is now starting to climb. So while we're waiting on the temperature, just a few things here. All the graphics that I used here for the agitator motor, the valves, the pump, the piping, the tanks, all of that are those are graphics that are built into the software, into TI Portal. That's very extensive graphics library. So when you are doing your HMI development, you don't really have to go outside and go grab graphics from somewhere else. You can pretty much use everything right there inside the software. So we've got a main menu screen. So the mixed tank screen is the one we were just on. We've got a holding tank screen, empty, as for future development. We've got a diagnostic screen, also empty. We're going to change that this afternoon. We're going to add a control here so that we can monitor diagnostics of our system. And then finally, we've got an alarm screen. All right, so the mixed tank has finished heating. We've gone into waiting for the holding tank to request product. We're just sitting here, we're recirculating, we're agitating, and we're just going to maintain the temperature. I've put a button down here at the bottom, hold tank empty. That'll make the sequence advance. So now we've gone to discharge. So the discharge valve opens, discharge pump starts. We'll start to see the level transmitter drop. All right, so what we're going to do today, we have been asked, it's our first day on the job, and we have been asked to add a high level switch right here at the top of the tank. Lucky level switch 13, we're going to call it LSH 13. So we've been asked to add this high level switch to the top of the tank. We want a graphic here on the screen that is red if we're in high level and gray if we're healthy. And that's a fairly simple task, but it does introduce us to a lot of the different things that we need to do here. First of all, we need to pick a spare IO point. That was their stipulation. Yeah, add that high level switch, but but you need to add it to an existing I/O rack to an existing digital input module. So we need to go find a spare I/O point. We need to create an alias for level switch 13, and I want to do it object oriented. I want to create a user-defined type that'll allow my HMI to monitor any level switch we're ever going to add. Then I want to create an add-on instruction. They're not called that. We'll get to that later. But we're going to use that AOI for every level switch we're ever going to add. We're then going to create or use that AOI, instantiate it for level switch 13. And then we're going to get up here in the HMI, and we're just going to add that graphic here to the tank. Again, it's going to be red if it's in alarm and gray if it's healthy. So again, fairly simple task, but it does introduce us to all the different components that we want to cover today. All right, so the sequence is going to idle. I could restart it, but I'm going to exit out of the HMI simulation, and I'm going to exit out of the PLC simulation. And I'm also going to exit out of TI portal once that shuts down. All right, so just a couple more slides here before we launch the software. Everything that we do today, by the way, is also documented here in the PowerPoint, click by click. You'll also get a copy after we're done today, a PDF copy of this PowerPoint. So with that, with the seed project, and you can download a free version of TI portal and use it for 21 days, you can recreate this this workshop sort of at your own pace. All right, so let's talk just a little bit about software before we launch it. So Studio 5000, to me, the term Studio 5000 from Rockwell, I've always sort of thought of that as a marketing term that describes all their individual software packages. So if you're going to program a control Logix or a compact Logix, you would have Logix Designer, standalone software package. It also programs compact Logix. We can also commission VFDs through Logix Designer, although Rockwell really wants us to use CCW or Connected Components Workbench, but we can still do it inside of Logix Designer as well. If you're going to program one of their HMIs, all three of those are separate software packages. If you're programming I was going to say the newest, but it's not, the newer panel view, the 5000 family, you would use View Designer, standalone software package. If you're going to program the older panel view plus 7, FactoryTalk View Studio, standalone software package. And then Rockwell announced a couple of years ago that they bought a company in Italy and they rebranded their HMI, and they're calling that FactoryTalk Optics. Fairly new. Earlier this year, I went to a seminar on it. I don't know what it really means for these two guys. Is this going to replace them? Not real sure. If you want to go full-blown SCADA system, and I don't show it up here, but then you've got FactoryTalk View SE or Supervisory Edition, standalone software package. And then FactoryTalk Optics also has a SCADA system, also a standalone software package. So again, Studio 5000, more a marketing term just to describe all their separate software packages. So let me ask a question. Do you guys, anybody feel free to chime in here? Which of these panel view products do you use, or are you using somebody else's HMI?
A little bit of both.
Both?
Yeah.
Everything but optics.
You got some optics?
No optics.
Gotcha.
No optics. Yeah, it's so new. Not a lot of folks have embraced that yet. So somebody in there has used View Designer?
Mhm.
So what are your thoughts on View Designer? I'll be honest, I have not used it.
I think the programming interface is a little easier in FactoryTalk View, and it seemed more basic, but it was easier to get done, I thought.
Okay, so a little more basic than FactoryTalk View Studio, but easier to use.
I thought so.
Okay. Anybody else have experience with View Designer? Okay. So Siemens and TIA Portal. So TIA Portal is not a marketing term. It is the software. and then you add components to that software that you need. And they're not standalone software packages. They're all integrated into the TIA portal. So if you're going to program one of their PLCs, like this 1500, and I'll talk about hardware a little bit later, what that 1500 means, or maybe the smaller 1200, you would add step 7, the TIA portal. If you're going to commission drives like this G120 drive, you would add start drive to TIA portal. And then we've got 2 different HMI offerings. We've got the newer WinCC Unified Comfort Panel. If you're going to program one of those, you would add that to TIA portal. Or if we're going to do one of the older comfort panels, still fully supported, you would add WinCC Comfort to TIA portal. So a good example, I've got a customer that standardized on the ControlLogix PLC. They're a natural gas facility in Louisiana, but they didn't really care for any of the HMI offerings. And so they ended up standardizing on the WinCC Comfort panel. This was before the Unified was out. I need to talk to them about stepping up to Unified. Anyway, so they standardized on Comfort, and I'll show you later today how easy it is to get one of these Comfort panels to talk to a Rockwell PLC. But so when they buy TI Portal, they don't need Step 7, they don't need Start Drive, they don't need Unified Comfort. All they buy is WinCC Comfort. Now, later, if they get a Siemens PLC in their plant, all they need to do is add Step 7 to their existing TI Portal installation. No need to buy a separate software package or a whole new software package. They just add that component into TI Portal. So a little bit different than what we're used to in Rockwell. When you launch the software, we're going to do that here in just a second with Portal. All these pieces and parts actually have names. So in Studio 5000, you got the menu bar, the standard toolbar, the instruction toolbox, the online toolbox. But we've got something called the controller organizer. And Rockwell calls it a controller organizer because it's a single controller per project. So if you've got 5 ControlLogix in your plant, you've got 5 project files, 5 ACD files. Single PLC per project. And then we've got the logic view window. I've double clicked on a routine over here, brought up the ladder. And then we've got the results window down below that pops up as needed. In Portal, we got a lot of the same components, title bar, menu bar, toolbar, but instead of a controller organizer, we have something called a project tree. And they call it a project tree because there actually can be multiple PLCs per project. Your HMIs can be in there, your VFDs can be in there. In this particular project, here's a PLC. Right, how do I know it's a PLC? Well, first of all, the very unfortunate name, PLC_1. But the icon also tells me that it's a PLC. And then in brackets, it tells me the model number. So it's a 1500 PLC. More on that model number a little bit later. But that's one PLC there. Here's another one. It's the smaller 1200 PLC. Here's an HMI. There's a drive down there. So controller organizer doesn't make sense. It's actually a project tree. And your project is made up of devices. Now, in this particular view, what I call the network view, I've double clicked over here on devices and networks, and we're going to do that a lot today. And as the name suggests, it shows me all the devices in my project and how they are networked together. So there's one PLC, there's the other one, HMI here, another HMI here, some IO devices. The task cards on the right automatically change based on what you're doing here in the work area. Because we're in the network view, the task cards have automatically changed to show me the hardware catalog, and now I can add things to my network, into my project, things like another PLC or another HMI or a PC-based SCADA system or a VFD, distributed I/O. And then down below is the inspector window. It just shows me the properties of whatever I have selected up here. And we're gonna live in this inspector window today. This is the network view. Here's the ladder view. I've come over here, I've double clicked on a routine. They're not called that, we'll get to that later. It's brought up the ladder logic here in the work area, and the task cards have automatically changed so I can do those ladder things that we love to do, like grab bit instructions and timers and counters. Here's the HMI view. I've come over here, I've double clicked on a screen. Notice it didn't, no smoke and mirrors here. It didn't launch a separate software package like the old Somatic Manager used to do. We are in the same project. Notice here's, still got the PLCs here, but I've double clicked on a screen. Got the screen and the task cards have automatically changed so that we can do all those HMI things that we like to do, like analog displays and push buttons, bar graphs. And sure, we can do a side by side. I can look at my HMI on the left and my PLC on the right. I can drag and drop between them. We'll see that a little bit later today. But all of that in one project and in one software package. So just a summary, and we'll launch the software. Projects in Studio 5000, single ACD file, single controller per project. If you're doing an HMI, separate software package. Drives are integrated in. Very limited library support. The two offerings that Rockwell has is ACM, or Application Code Manager, and Architect. Anybody in there used either one of these, ACM or Architect? Nope.
Doesn't look like it.
Yeah, you know, I think in all the years I've been teaching these workshops, I think maybe 2 or 3 people have seen either one of these. Yeah, they're not very popular. They're fairly difficult to use. I think that's why people really don't use them very much. But we also know that firmware and software versions have to match. If you're programming a version 33 firmware, you got to have version 33 software. And if you have version 34 software, that doesn't mean you can program version 33 firmware. It's not backwards compatible. They have to match in lockstep. A little bit different in Portal. We don't have a single ACD file. We have multiple files and multiple folders, which sort of makes sense if you think about it. If you've got multiple PLCs and HMIs in a project, it would be hard to cram all of that into a single file. Actually have multiple files and folders. We know that we can have multiple controllers per project or none. My customer in Louisiana, when they create a TI Portal project, remember they've got Rockwell PLCs, so their Portal projects only have HMIs in them. Multiple HMIs per project or none. Drives, none. Projects can be archived down, so those multiple files and folders, you could archive them down into a single file so that you can email it to somebody or throw it up on a network share for archiving purposes. Much easier to manipulate a single file as opposed to all those files and folders. Very mature library functionality in Portal. Hopefully we can get to that this afternoon. But the latest version of software can program all previous versions of firmware. You don't have to lockstep your software version to your firmware version. You don't have to worry about that. Okay, so remember our goal today. Our goal today is to add a high level switch to the top of this tank. So we're going to add level switch 13 to the top of this tank. All right, so let's say it's your first day on the job and you've been asked to do this. And let's say it's a Rockwell facility. All right, well, the first thing that you would probably do, first thing I would do, is, okay, well, what kind of PLC am I dealing with here? Is it a control Logix? Is it a compact Logix? Is it a guard Logix? Is it safety? And so to do that, I would open up the project, I'd go to the properties, and I would check it out. And so you can see that this particular project is using the L75 controller. Version 34 firmware, which means I have to have version 34 software. Of course, the name, the description. And we know that Control Logix is a slot-based chassis system. So you got 4, 7, 10, 13, and 17 slot chassis. If you want to go to another chassis, if you fill that one up, you drop in an Ethernet module, grab another chassis, and now you got another 17 slots. We know that the PLC can be in any slot in that chassis, and you can actually have multiple controllers per chassis. All right, so a lot of difference here on the Siemens side. We know that we don't have to worry about the firmware. Neither the 1500 nor the 1200 are chassis-based hardware. The modules mount on a rail, and the PLC is always the module furthest to the left, other than any power supplies. And you can't have multiple PLCs per rail. Now, we can exchange data between PLCs at I/O rates, very, very high speed, but they're not going to be sitting on the same rail. The next thing you might do, okay, they said, all right, I'm adding this high level switch 13. I know that's a digital input. They said that I need to use an existing rack and an existing slot. So I go down here to the IO configuration and I see, okay, well, what kind of IO am I dealing with here? Well, the IO configuration in Rockwell is shown in this sort of this non-graphical tree view. And you see the structure based on how it's indented in. And so the local backplane is here. There's my processor in slot 2. I've got an EN2T module to open up my network in slot 3, but I don't have any other local IO modules. So there's no local IO. Instead, I've got this Ethernet network. Here we go. Here's some 1734 or point IO. I've named it IO mix tank. There's an 8-point digital in, an 8-point digital out, and a 8-channel analog in. All right, so they told me we're adding it to the mix tank, digital input. So I gotta find a spare digital input somewhere on here. All right, well, how do I do that? How do I know what's spare? How do I address IO? Well, we know in Rockwell that IO is addressed based on the chassis name, the slot number, and the type of the IO module. And so for an IO point on that digital input module, it would be somewhere in this range, IO mix tank :1:I.0 through .7, 8-point digital input module. So how do I know if one of these digital inputs is spare? Well, I would need to go do a search or a cross-reference and find out, okay, which one of these is not being used. And through those searches, I have determined that this guy right here is spare. IO mix tank :1:I.6. This is where we're going to put our lucky level switch 13. All right, well, we don't typically, and hopefully you don't, typically we don't program with what I refer to as the ugly tag name. Now, this is not a Rockwell. I call the Siemens one an ugly tag name too. I'm not, I'm using the term equally, but hopefully you don't use that tag. Instead, in Rockwell, either we create an alias or we buffer IO or we map the IO. So let me ask that question. Do you guys typically alias or do you buffer or map your IO?
Buffer.
Buffer. Let me ask a question. Why do you prefer buffering over aliasing?
It's easier to find.
Easier to find? I agree.
You can do it right in the ladder logic.
Yes, you can do it in the ladder logic. One of my gripes about the alias is you cannot change what it points to online with the PLC. Either you have to go offline, change it, download, which as Rockwell programs, we know that means stop, or you rename the old alias, you create a new one, you point it to a new location, you find everywhere the old one is used, replace it with the new, and you run the risk of making a mistake. And so we buffer as well. And if you're not familiar with buffering, all you're doing is you're just writing logic that says, okay, if this ugly tag right here is on, then you're going to energize another tag that's a nice tag. So the other problem is the way that Rockwell scans its IO. Here is an alias if you've never seen it before. But the way that Rockwell scans its IO and executes its logic is different than the way Siemens does it, and most other PLCs, in fact. So the way that Siemens scans is it reads its inputs. Those inputs are stored in a non-volatile area. No chance that they're going to change state in the middle of the program scan. The program scan happens based on the results of the logic. Updates or outputs are updated. And then we do a little bit of housekeeping, communications, things like that. And that happens forever and ever and ever. Logix doesn't scan that way. Digital inputs updated an RPI or requested packet interval. DOs do the same. Logic is scanning asynchronously. Communications are happening asynchronously. So you could have a digital input that's on right here in your logic and off down here in your logic. And so if that's a problem, it causes you issues with your logic, then you need to buffer IO. And here's just a tech note from the Rockwell website confirming what I just described there. But all discrete input data is completely asynchronous to the program scan. and may change at any time during the program scan. So a problem, then you have to buffer your IO. All right, so let's do that exact same thing, but inside a TI portal. Let's go look at the controller properties. Let's look at the IO layout. Let's pick a spare IO point, and let's create an alias at a point to that digital input. So on your desktop, you should have a shortcut to TI Portal V19. That is the latest and greatest version of TI Portal. It was released in November. But let's launch TI Portal V19.
I'm that. Oh, because I forgot my reading books. Yeah. Just remind me to break that. There's my kind work on the other side of the quarry. I'm gonna run down here at lunch. They have them everywhere.
So when TI Portal first launches, and it looks like I launched 2 versions of it. I don't need 2. It launches in what's called Portal View. And this is going to depend on who last used your PG, whether it's in Portal View or not. I'm going to assume it's whoever used it last left it in Portal View. But Portal View is, I sort of think of it as the beginner view. It gives you some shortcuts and some wizards to do some common things, you know, open existing projects, creating, migrating, taking a welcome tour, seeing what software you've got installed. I don't really know anybody that uses Portal View. Typically, we immediately swap over, or actually we just set the software to automatically start in what's called Project View. So down in the bottom left-hand corner, you can see a link to Project View. So let's click that. Let's go to Project View. Assuming this is the first time you're seeing the portal software, here on the left is the project tree. Again, down below, we call it the inspector window. Over in the right, those are the task panes. And each one of these sections can be resized. If you just hover your mouse over the border, you can resize those if you're wanting to maximize your work area. Let's see. And then each one of those sections has a little white triangle that you can completely collapse that section if you wanted to. So really maximize your work area there in the middle. And you just hit it again to bring it back. And then the one on the right and the one on the bottom, these guys can be floated with this button. And so if you're using dual monitors like I am, you can float that window, move it over to your other monitor. It's still up over there, but it maximizes my work area. I can bring it back and dock it. You can also save your window layout. So if there's a particular layout that you really like for, let's say, HMI development versus ladder logic, you can do a window and save window layout as. And that way you can save your favorite window layouts. That's also helpful if you have to share a programming resource and somebody gets bored over the weekend and they leave the layout looking something like this. Not very helpful. So if you've got a window layout that you've saved, you can very quickly go back to it. All right, so let's open up the mixed tank project. So on the toolbar, there is the project open on with the little folder with the green arrow on it. Let's click that. And we're going to open up a archived project file, meaning all those files and folders that I described have been compressed down into a single file. That's an archive file. So we're going to open it up. Once you clicked open, like any good Windows application, it keeps up with the last few things that you have opened. But let's click browse. Let's go find that seed project. And I believe they said they put it on the desktop.
Yes.
And you should see a file called mixtank.zap19. So that zap tells you that it is a zipped up TIA portal project that was created in version 19.
So it's not doing this .zap 19 on our.
Yes,
machines?
because the way Windows is set up, it's hiding the extension. Yeah. That's that Windows setting that hides known extensions. But let's select that Mixtank file and let's click open. It's going to pop up another dialog box. Everybody wait once it does that. Let's select the Mixtank and click open. And notice the new dialog box is saying select target directory. So it needs to take this single file, expand it out into all those multiple files and folders, and it's just asking, okay, where do you want me to put this project file? And by default, I think it probably puts it in documents, automation. That works for me. If you want to put it there, documents, automation, that'll work. And then click select folder. If it pops up and says that directory already exists, you want to overwrite it, say yes. We use these PGs a lot for this particular class, so there may or may not be a an older version of the project still on there. All right. So again, let's look at the project tree. Let's start there. Notice the very top level here is the project, Mixtank. And then the tree underneath it shows you all the different devices and folders that make up a project. And we can see we've got a PLC. How do I know it's a PLC? Again, the icon. Notice my naming convention. I use camel case, and then I start it with what the device is, PLC, and then where it is, Mixtank. And then we've also got an HMI here. So the black triangle next to the PLC tells us we've got a lot of other stuff underneath there. So let's click that black triangle, expand the PLC, and let's see all the different folders that make up a PLC configuration. So a lot of different folders here. We're not going to get to all of these today. We'll get to a lot of them though. But the first thing that we did in Rockwell was we went and looked at the controller properties. There's several different ways that we can do this, but let's do it this way. Let's double click device configuration under the PLC. So right under PLC Mixtank, double click device configuration. Now remember, in the Rockwell PLC, it was a 1756 L75 processor. Let's see what we're dealing with here. So we need a double click right here. under the PLC. Now, what you're going to notice with TI Portal is it is a very tab-driven software. Notice we have tabs up here, topology view, network view, device view. We've got tabs down the side over here, hardware catalog, et cetera, et cetera, et cetera. We've got tabs down below. And even those tabs have tabs. And that can be a little overwhelming at first. But what you'll find, the more that you use TI Portal, you'll find that those tabs really allow you to navigate very, very quickly through your project. Yeah, you got to learn where the tabs are and where stuff is stored on those tabs, but that's true of any software package. It really is a quick way to navigate through the software. All right, so first of all, let's take a look at this hardware. All right, there's our PLC right here. Got a power supply and a power module. Do we have any local I/O? Well, notice we can go all the way out to slot 31. These black triangles just let me know that those slots are collapsed. If I expand those, you can see, nope, no local I/O. So just like in the Rockwell project, we don't have any I/O that's local to the PLC. And remember, they told us, hey, you can't add any I/O modules. We want this added to an existing I/O module. Now, because we're in the device view here, notice that the task card over here is automatically changed to the hardware catalog. So I could add modules from here. So I wanted to go and add a digital input module. I could, or a digital output module. Here's a question for you. Why does Siemens call digital output modules DQs instead of DOs? And analog output modules are AQs instead of AOs. Any idea why?
Because in German, they probably got some 40-syllable letter.
I appreciate you saying it because someone always says it in these classes, but no, it is not a German thing. All right, we'll get to that later. All right, well, let's take a look at these controller properties. So down here, I want you to come and click on the Properties tab. Click on the Properties tab. And remember, it's going to show us the properties down here of whatever it is we have selected up here. So we want to make sure that the PLC is selected. And you got to be careful where you click. If you click right here, that's going to click or select the entire rail. And that's not what we want. And if you click somewhere in here, you're going to select one of the communication ports on board the PLC. And it's only going to show you the properties of that communication port. Click somewhere in here, or you can always just select the name up here. So we're in the properties window, we're on the general tab, and I've got the general list item selected. So with the PLC selected, properties, general. So right at the top there, we can see the name of the PLC and who the author was and a comment and a rack and a slot. But I want to scroll down here so I can see the catalog information. So scroll down to the catalog information. So we can see that the short designation for this PLC is a 1516-3PN/DP. All right, well, what does all that mean? So someone tell me, what is the difference in Rockwell? What is the difference between an L71 processor and an L75 processor?
The memory.
Exactly. The amount of memory. And there's some communication connections as well. But yeah, as you go up in number in Rockwell, you also go up in memory. And you got the same thing here in Siemens in the 1500 family. So this PLC is a 1516. Well, the 1500 family starts way down at a 1511 and goes all the way up to a 1518. So the 1518 is the biggest and baddest PLC that Siemens makes. As you go up in number, it goes up in memory. And in Siemens, it also goes up in performance. So the 1518 not only has the most memory, but it's also the fastest PLC that Siemens has. So this 1516 right here, it's sort of an upper end PLC, only two better than it, the 17 and the 18. All right, the -3 at the end. That tells me how many communication ports are on board. This is the X1 port. This is the X2 port. And this is the X3 port. And I know that X1 port looks like 2 ports, but that's just a built-in Ethernet switch on the front of the PLC. Most of the Siemens hardware has that built-in Ethernet switch. The VFDs have it, the HMIs have it, the PLCs have it. But X1 and X2 are Ethernet ports. And X3 is what's called a Profibus DP port. Now, if you're not familiar with Profibus, it's a legacy protocol. In my opinion, it's an RS-485 based network, hugely popular in the 90s and early 2000s. There's still a lot of Profibus devices out there. So some of the PLCs you get from Siemens has a Profibus port on board, but not all of them. But every Siemens PLC that you buy, both the 1500 and the 1200, have at least one Ethernet port. You cannot buy a 1500 or a 1200 without an Ethernet port on board. And that's what the PN/DP at the end tells us. There's Profinet on board. That's the protocol of these Ethernet ports. And there's also a Profibus DP port on board. So that's what all that means. There's also a bunch of long description here about all the capabilities. I'm not going to bore you with that. But then we've got the long Siemens part number that I hear a lot of people complain about. So if you're going to order this PLC, this is the part number you got to use. All right, so what is all this trying to tell me? Well, to make it a little easier, the 6ES7 at the beginning, that puts you in the PLC IO family of hardware. The 5163 here obviously corresponds to this. The A right here tells us that it is not a safety PLC. Anybody in there use guard logics or compact guard logics safety? Yep. So Siemens also has safety PLCs. If this were a safety PLC, there would be an F right here for fail-safe. Right? It's an A, means it's not a safety PLC. The P right here tells us it's not a technology PLC. Siemens has some very high-end PLC models for motion control. Now, all of them have motion control capabilities, but if you've got really, really advanced motion control requirements, you may want to go with a T processor or a technology processor. But that P right there tells me this is not a technology PLC. And then finally, the rest of this 03, 0AB0, that's just the way Siemens keeps up with what chipset is inside that PLC, the memory chips and the processors and all that. Notice the version 3.1 firmware here has nothing to do with version 19 software. We don't have to worry about keeping those things lockstep that way. All right, so that's the controller properties. One more thing I want to show you while we're here, though. Come down and click on System and Clock Memory. System and Clock Memory. I like to show this area to Rockwell programmers because it gives us some interesting tags or useful tags. And by default, these are not enabled. So the first thing I do when I add a PLC to my project is I come in and I click this checkbox and I click this checkbox. All right, so why? What does this give me? Well, the first thing it gives me is a first scan bit. Anybody know what the first scan bit is in Rockwell?
S115.
Okay, so for the older, the slicks and the fives, yeah, it's S115. What is it in a control-logix?
S:/FS.
Yep, S:/FS. S:/FS. That's the first scan bit. And so what do you do with that? What's a good example of what you would typically do with a first scan bit?
That a whole bunch of things false at startup?
Set a bunch of stuff defaults. Reset totalizers, reset runtime counters, whatever it is you need to do with that process or that machine when you're coming up from a power outage, let's say, you would use the first scan bit. And so you could do the same thing here in Siemens with this first scan bit. It does the same thing. There's another way that we do it inside of Siemens with a startup organization block, but we'll get to that later. We've got an always true tag. A lot of times in Rockwell, we'll get online with a PLC, we'll put an empty branch around some logic just to temporarily energize an output. Okay, well, we can't do that in Siemens. We can't do an empty branch. So instead, what we can do is we can throw a normally open contact, use the always true tag, and you've branched around some logic. And then also the always false tag. You know, a lot of times we'll throw in a AFI instruction inside of Rockwell to temporarily disable something. Well, we don't have an AFI instruction in Siemens, but what we can do, throw in a normally open contact, throw in this always false tag, you've disabled some logic. And then the clock memory bits. These are just some useful tags that turn on and off at the described frequency. So like this one right here, clock_1HZ. That is a tag that's on for a second, off for a second, on for a second, off for a second. So imagine you've got a light on the front of an enclosure that you want to flash on and off when there's an alarm condition. Sure, you could do it with 2 timers, write some logic around it, but you could also just use this. That's what it's there for. You can go as fast as 10 hertz and as slow as half a hertz, which, if my math is correct, that's 2 seconds on, 2 seconds off. All right, well, the next thing that we did in Rockwell was we went and looked at the I/O configuration. So we see that we have no local I/O. So where's our I/O? So there's a couple of places that we can go and find that. One, notice there's a tab up here called Network View. Let's click that tab. Network View. You can also get there by double-clicking Devices and Networks. Takes you to the same place. Ah, here we go. So the network view, again, as the name suggests, shows me all my devices in my project and how they're networked together. I can see my PLC here. I can see my HMI. There's a legacy HMI way down here. There's some I/O. Notice that it also references right here PLC mix tank. Why does it do that? Well, remember, we can have multiple PLCs in this project. And so every time you drop some I/O down, you got to tell that I/O who is my I/O controller. Now you can actually multi-assign I/O, so you could have 2 different PLCs assigned to that I/O, but only one of them can be the controller. The other one can just listen. You know, so if you've got an analog input you want to send to 2 different PLCs, you can do that. So this button right here in the toolbar, the one with the eyeball staring into your soul, if you hover your mouse over it, just hover your mouse over it, it pops up some help. And if you keep your mouse hovered over it, it expands it down with even more help and then a link to even more help. So if there's a button that you're really not sure what it does, hover your mouse over it. It'll give you a ton of information and then even a link to the help system. And so you can see that if we click this button, it's going to show the address labels. So let's click it. Yep. As the name suggests, there's all the IP addresses of all of our Ethernet ports. And you can change the IP address from here as well if you wanted to. We're virtual today. It really doesn't matter what our IP addresses are, so we're just going to leave them where they are. All right, but we want to look at the I/O. I need to find a spare digital input, and we got to figure it's in this I/O mix tank. So let's double click it. Let's zoom down in here, take a look at what we got. So double click I/O mix tank. And you'll see all it really does when you do that, if I double click IO mix tank, all it really did is just took me to the device view tab for that rack. So this family of IO is called ET200SP IO. It's very, very similar in footprint to Rockwell's Point IO, very similar in cost point. IO densities are very similar. We could do safety IO here as well. This is a Profinet adapter in slot 0. Notice the built-in Ethernet switch. Siemens power supply right here. It doesn't have to be a Siemens power supply. You can use anybody's power supply, but I like to use the Siemens power supplies because I get diagnostics back from them. And we'll see diagnostics later on this afternoon. We could go all the way out to slot 33. A lot of IO. Oh, I should mention too. So this is, I mentioned this is the Profinet communication adapter. There you could put an Ethernet IP adapter. So if you wanted to control this IO with a Rockwell PLC, you could. You could put a Modbus TCP adapter there if you wanted to control this IO via Modbus. I don't know why you'd want to do that, but you can, because Modbus just won't die.
Hey, Ron, question for you on that. TCP IP versus the Profinet. So this guy really doesn't care. You plug a Rockwell controller into him and he's TCP IP ready to go.
Yeah.
Wait.
So, yeah, so you would get a different, bus adapter for TCP IP.
Okay.
Yep. But
Oh yeah,
otherwise-
gotcha. Yeah, it's a different part number. There's one called an MFP, I think is what it's called, and that one you can actually do Modbus TCP, Ethernet IP, or Profinet, I think, all in one adapter.
Correct. And all three at the same time, interestingly enough. We could have Profinet talk to some modules, TCP IP talk to other IO modules, and then Ethernet IP talk to, yeah, you can mix it up all in one station.
Yeah,
Just came up
it's
a couple of years ago. It's pretty slick.
yeah, it's crazy. Don't remember where those are located. Also, I should mention that instead of a communication adapter here, you could actually have a PLC here, an ET200SP CPU. It programs just like a 1500. There is a 1510, a 1512, and a 1514, and there are safety versions of that, so with an F on it. I've got a customer here in Mobile that actually standardized on the 1512F version. So smaller footprint, lower cost point, not as much memory or as powerful as the full-blown 1500, but depending on what it is you're doing, it's a great PLC. All right, well, we can see the IO layout is the same as what we saw in Rockwell. In slot 1, we've got an 8-point digital in. In slot 2, we've got an 8-point digital out, again with the Q. That is not German. We'll get to that later. In slot 3, there's an 8-channel analog in. And in slot 4, we've got something called a server module. I don't really like the name, but if you've ever done Rockwell, like Compact Logics, you got that right end cap resistor at the end. That's what the server module is. It just terminates the IO bus. All right, so we know we need to pick a spare digital input on this card right here. All right, well, how do I address IO on this digital input? Well, let's come down to select the digital input. Select the digital input module. Again, careful where you click. If you click the number 1, it's going to select the entire rack. That's not what you want. So you want to click somewhere in here. But let's select that digital input module and come down to its properties. So digital input, properties, and I want to come all the way down, expand this input 0 through 7, and select IO addresses. This is probably the first biggest difference, huge difference from what you're used to in Rockwell. In Rockwell, the ugly address is based on the rack name and the slot and the type of the I/O module. That is not the case in Siemens. Notice that the start address and the end address right here are 0.0 through 0.7. This 0 has nothing to do with the rack name or the slot number. As you add I/O, the software automatically picks the next available address space inside the PLC. Now you can change it. Notice that it's changeable, but you're never going to get it to line up with a slot number and a rack and all that. All right, so why? Why does Siemens do it? Why does Siemens do it like this? All right, so I'm guessing here, but let me jump back to my PowerPoint real quick. Come back to the I/O layout for Rockwell. All right, so let's say we designed this I/O rack and we did our due diligence and we include 20% spare I/O. But lo and behold, all of a sudden, this digital input module is full and we need to add another digital input. So in Rockwell, there is no way that we would come in and insert a digital input module right here, because that would shift these two guys down, which would change their ugly addresses. So then we'd have to go change all of our aliases or all of our mapping. That's going to introduce a lot of work, but also room for error. And so instead, what we would do is we would just tack on that digital input module at the end. And if you're somewhat OCD like me, I really like all my digital ins to be together and all my digital outs to be together. And so you can't do that in Rockwell. Well, in Siemens, we could absolutely do that. So in Siemens, I could come in here and I could insert a digital input module right here, shift these guys down, and wouldn't have to change a thing because their addresses are not based on the slot number. Different way of thinking. I'm not saying one is right and one is wrong. I'm just saying they approached it two different ways. All right, so I know I need to pick a spare digital in somewhere between 0.0 and 0.7. Well, how do I address that? And how do I know if something is spare or not? Well, let's click on this I/O tags tab right here. Click on I/O tags. So here is where we can actually assign nice tag names to the ugly tag name. Remember that this input module was 0.0 through 0.7. So the way that we address I/O is a %I for input, obviously, and then the address that was assigned to the module, 0.0 through 0.7. And then this column allows me to assign an alias, they're called PLC tags, to that ugly address. My naming convention, I like to do DI underscore for digital inputs, and then I just use the IEEE naming convention for instrumentation. So that's my steam valve 11 closed feedback. That's my steam valve 11 open feedback. There's valve 12, the discharge valve. There's the lid switch. We're going to use that later today. Lets me know if the lid switch is open or closed. And then I've got my feedback running from my discharge pump. All right, well, notice that input 0.6 and 0.7 have no tags assigned to them. That lets me know that they are not being used anywhere in the PLC, in the logic, not being used. If I went into my logic right now and I dropped down a normally open contact and I typed in %I 0.6 as the address, the software would say, hey, you don't have a tag assigned to that address. I'm going to go ahead and do that for you. And it would be tag _1. Horrible name. But the software enforces that. So the fact that there is no tag here tells me that this guy is spare. He's not being used anywhere in the logic. I don't have to go and do a search or a cross-reference. I know from right here, not being used. So let's go ahead and type in our alias for our lucky level switch 13. I'm going to type it in and then I'll zoom in so you can see it. 0013. Of course, we want to put in a good comment. Mixed tank high level switch. So everybody type in that PLC tag. And again, make sure you put in a comment. I'm begging you. And I'm going to beat that horse all day long about commenting code.
You guys didn't discover these German keyboards are a little different too. Can never get used to the shift key.
So when I got PCS 7 certified initially, it was a 2-week class and we used these PGs. And by the end of those 2 weeks, I actually had gotten used to the keyboard, but then couldn't go back to my other one. Yeah, I use a wireless keyboard here. I don't try to type on the PG. Notice this column right here, tag table, default tag table. Keep that in mind. We'll come back to it. All right, so hopefully everybody's got that typed in.
I have a question.
Good.
Can you hear me?
Yeah, I can. Go ahead.
You mentioned IEEE IO naming convention. I was just curious what document or where that comes from.
That's a good question.
It's an ISO standard.
Is it ISA?
It's ISO.
It's ISO. Okay. I couldn't remember which one it was. I learned it back in '93, and then I haven't ever looked at it again. ISO instrumentation naming standards.
That's as ISA. I know I read it under ISO.
Oh yeah, you're right. You did say ISO.
Oh,
Yeah, and, you know, typically if you get a good set of, you know, P and ID drawings, you know, either, you know, your own or you engineering firm or something, you know, they're going to use this standard. So it's nice, as Ron said, then if you name your tags, then it's very easy to cross-reference, you know, between different documents. Your PLC code matches with your P and ID drawing, the names are the same.
Yeah, this exactly what you just said. From a P&ID drawing, typically whoever is doing your P&IDs know these standards and they name everything accordingly. But I have seen a lot of variability from engineering firm to engineering firm. So, but yeah, it is ISO.
Okay,
I think there's a bunch of different ones that do it. Like here's ISA, and I think all of them are fairly similar. But great question. All right, click on the digital output module in slot 2. So digital output module in slot 2. Notice we've got the exact same IO tags tab. Here, my naming convention DO underscore. Notice the ugly address %Q 0.0. This is to energize the steam valve, valve 11. Has nothing to do with a physical slot location. Again, with the default tag table. One more, let's click on the analog input module on slot 3. Click the analog input module on slot 3. Notice the naming convention, AI underscore for me, and then level transmitter 11 is the level, temperature transmitter 12, and then I've also got current feedback from the discharge pump. Notice the ugly address, %IW. What does the W stand for?
Word up.
I'm sorry, say again?
Word up. Word up.
Word up. Thank you, Cameo. Yeah, so the W stands for word there. Because this is an analog input, it has to reserve an entire integer in the address space. And so it's letting you know that, hey, I've taken a whole word out of there. And in like the old Somatic Manager Step 7 Classic, you really had to worry about that, you know, but how things were sliced and diced between bytes and words and doubles and integers. But we really don't care in TI Portal anymore. I'm not going to program with this. I'm programming with this. Now, what you do behind the scenes, TIA portal, to reserve that in the address space, great. But I'm going to use the AI underscore. Okay, again with the default tag table. Let's go find that. We'll have just a little bit there, and then we'll take our first break of the morning. But let's go find this default tag table. Well, these tags, these IO tags, are known collectively as PLC tags. And there is a folder under the PLC called PLC tags. If you expand that folder, lo and behold, there is the default tag table. Let's double click, open it up, see what we got in there. Under PLC tags, double click default tag table. So as expected, if you double click there, you can see there's our nice tag names, the DI underscores, the DO underscores, the AI underscores, showing me the ugly address as well. Got some additional columns out here. We'll cover those a little bit later today. %I's and %Q's, but notice what else we see in here. Remember that first scan bit we talked about, and the always true and the always false and the clock bits? Those are also in here, but they're %M's. All right, those are just internal memory areas. They're not digital ins, they're not digital outs, they're not analog ins or analogs. Those are just internal memory bits or memory areas that the PLC uses to keep up with things like a first scan bit or a clock bit. So we could come in here and create tags using %M's, but this is not where we're going to come and create our tags. We're going to use something called a global data block. We're going to get to that a little bit later. But if you scroll to the bottom of this table, notice we could do an add new down here. There's the one we just added, by the way, Lucky Level Switch 13 sitting down there. So instead of going to each IO module, you could come right here to the table, add your tags here. As long as you know the ugly tag name, you could fill them in right here. Or, this is what I do, you export the entire table to Excel, and this is a native Excel file. It's not a CSV file. Export it, create all your IO tags in Excel where you've got all that good search and replace and copy and paste functionality, and then just import it right back in. And at the start of a project, that's what I do. When I'm first laying out all that IO, I'll lay out the IO, get the ugly addresses, then jump into Excel, and then create all my tags in Excel and import them in. And you don't have to put everything just in a default tag table. That's a terrible name. Notice you could create your own tag tables. And so if you wanted to create a tag table for each rack, you could do that. Each area of your process, you could do that. It just allows you to organize your PLC tags into more manageable pieces, as opposed to them all being lumped right in here into default tag table.
They can only reside in one table at a time, right?
Correct. And so then if you're wondering, okay, I know I've got this IO point, but I don't know what table it's in, that's where you can double click show all tags. And it'll open up and show you everything. But you are correct. It can only be in one table. And likewise, if I came in here and I tried to create a new tag, don't do this. Hey, don't do this. And I try to reuse the same. Doesn't like that, obviously. All right, so back to the PowerPoint real quick, and then we'll take our break. So like I said before, everything we've done today, notice click by click, is documented here in the PowerPoint. You'll get a PDF copy of the PowerPoint so you can go and recreate this workshop sort of at your own pace. All right, let me get down here. We did all of that. So when you actually use a alias in Rockwell, you got the description up top, you got the alias, and then you got the ugly tag name down below. We've got something similar in Siemens where you've got the ugly tag name up top, description, and then the PLC tag down below. Remember, this %Q0.2, that doesn't tell me anything about the physical location of that digital output. Now, I'm going to show you later how you can go from right there to the physical location. But just by the address, we cannot tell where this thing is located. Also, we all described how we don't like with an alias that we can't change what it points to online with the PLC. In Siemens, we can actually rewire, that's what the process is called. We can rewire a tag to point to a different IO point without stopping the processor. So we don't have that limitation that we have with aliases in Rockwell. So no need to map IO. We don't do that in Siemens. Quick term to remember, and we've got a bunch of these throughout the day, but in Rockwell, you call them an alias. In Siemens, they're called a PLC tag. Other than that, they are pretty much interchangeable. So on our quest to add this high-level switch 13, so far we've picked the spare IO point, we've created the alias. When we come back, we'll talk a little bit about hardware, and then we'll start doing some programming, creating user-defined types and things like that. Any questions before we take our break?
But here, I think.
No questions here.
All right, so I'll start a 10-minute timer. We'll take a 10-minute break, and then I'll see you guys when we get back.
Thanks, Ron.
And so that's the reason that, right?
Yeah.
So flex cross reference that.
So that's because you.
But what about,
Right, so.
if we go, well, it is time back, that, so.
Right, so if you go to. So, yeah, so you just.
So, yeah, that's when I looked at them, like, the device of networks, like, I know it's tied to here. So if I did, so he, let's hear that.
Right, oh, I see. So.
Because this is obviously don't need anything else, you know, because. It didn't, right?
It was.
Steps. Yeah, we've done.
So. There's a.
Okay.
The cross.
Because there's a lot of, yeah,
Exactly.
yeah.
So we used to know what exact, but it is on the device. If you go to just, it's,
Okay.
then it takes. Alright, yeah.
I figured you would have gone through that. Yeah. So, yeah.
I also.
That's,
So
yeah.
that, but we were gonna just get over that.
There's many times I've dropped at somebody's place and like.
You're like, okay, which device, which one will react? Yeah, that's gonna, and that should work.
Yeah, we love.
That's gonna work on any of the functions.
Yeah, basically that.
Yeah.
Okay, thanks. Yeah, it's stupid.
Hey, Ron, can you hear me?
Yeah, I think, yeah, well,
Yeah, so.
you can take it, we don't have to stick with us.
No.
Yeah.
So that's.
Okay.
So the one. That one is pretty similar. Exactly. But we'll be sending the one.
Yeah, pretty large. I think it's sounding a large. If you send it, you have like a large file. Like. Yeah. You could. I'm gonna take notes and I see you back to the PowerPoint, these are other steps. This is good stuff. Yeah. Yeah. I know. Yeah. My problem is I grew up without wireless, so I got too much of that stuff in my head, trying to come into keep it over here while I'm figuring this out. Yeah. It's right. Yeah, he does, he does. Same here, I went down, up and down in time, so I gotta see.
This is the hard. It's from. The application that's the already demos and, sometimes students version 4.5. Of those things use for workshops. But if one day workshop, we just do software. Yeah, oh yeah, absolutely.
Maybe typically use that as for like a 2-day course, right?
You already. Just going for Christian and you generally things of room, and then we'll use it to. So
Yeah.
if that's something you're interested in. I never thought or go.
Yeah, that's kind of. Other, so the next class, yeah, Malvern is actually Cisco. Yeah, it's like it's a new course that teams came out, it's the workshop that teams came out this year, and we're actually the first site the US, I think, hosted. But it's more like networking, so it's Cisco to Scalar. So
Similar concept to the just on the net. So they
yeah, that's realizing I can make it interesting. Yeah, like I think the goal with that is it's like, there's million basis,
Yeah.
million basis in the cat. It's like, let's keep people how to be more efficient. So you're not spending as much. I'll send you guys, it's probably in June. We have like a mix of like, we have church opportunity, we have like universal robots, core training coming up. We're doing some cognitive classes. Yeah. Yeah, like we typically do cognitive are. Then we have I don't know if any Chris do a thank you. I don't know if you can thank you. We do a huge trade show every October. We do it at Valley Forge. But that's just like all of our vendors on. Yeah, presentation. I mean, you can see the stuff from the vendors, but the clients and people pick and choose for little things that people feel. Yeah, you like a mini trade show if you've been to like Pacnics. Always.
So I think,
It's fun.
I think we already did an REU one at the beginning of the year. So we might not have one on the schedule at the moment. But if there's enough of a demand and we have the availability in. Yeah. RE, I think honestly, the year went by so fast. I can't remember if it was earlier this year or later last year, but then there's we have an IO link and a unified one coming up also. So if you see the potential for using.
Yeah. Maybe think we also have you there.
Already.
Yes.
Yeah. Some people use it, some people. Yeah, it's great. Yeah. Anyway, so. Yeah, it's kind of doing the thing that some people are like. And then I mean, it's still that. It's very good.
Think they're pointing
Yeah.
Yeah.
Really relates to verbs, reminds. Say something for failure publics. All I know, points, things like that, you're gonna get that.
Rest of the games.
This is how long.
Oh, this is when.
Full time ago.
Hey, Ron, can you hear us?
I can.
Awesome. I was wondering if really quickly before you jump back into the rest of the presentation, would you mind showing just a moment ago you had one of the IO tags pulled up. Would you mind showing the feature where you can right click and go to device view and see? There were a few people here that were interested in just walking through that really quickly.
Yeah, sure. So,
Awesome.
I show that a little bit later today from
From
Ladder
sorry.
Logic.
Okay, that's perfect then. That's fine.
Okay.
As long as we get to it at some point, that'd be awesome.
Yep. It's part of the
All right.
presentation. Don't steal my
Thank
thunder.
you. Yeah, I'm so sorry. Thanks so much.
Sure.
All right, we're ready. We're ready here.
All right. So let's get restarted here. Hopefully everybody got a cup of coffee and ready to go. So let's talk just a little bit about the hardware. Again, I don't want to spend a lot of time there since we are virtual, but I do want you to know the major players. In Rockwell, we know that the Control Logix is the flagship processor, if you want to use that term. We can do safety there. We can do redundancy there. It's got its own family of IO, the 1756 IO. And that's going to be the 1500 family on the Siemens side. We can do safety there. We can do redundancy there. It's got its own family of IO, ET200MP IO. That display on the front, by the way, we use it a lot in the hands-on workshops. You get a ton of information from those displays. And actually, I've got one. Let me turn my camera on real quick. All right. So if I stop sharing. There we go. All right, so you should be able to see that's I've got my camera zoomed in on the display of a 1500 PLC. So just right off the bat there, notice that you can see, of course, the model number, the IP addresses. Notice the F there in the name. That is a safety PLC. But some of the information that we can get here, diagnostic information. So I can actually cause an alarm to happen. And so I've got a high temperature alarm. I've got a process simulation running in here. So I can get process alarms from here. I can get diagnostic alarms from here. So if I lost communications, let's say to an IO module, I can get that out of there. Notice that I've got this new message, hardware component removed or missing. Arrow down to it here. So hardware component removed or missing from the rack IO machine B. It's the digital output module. So tons of information right there from the display. And as I mentioned, when we when we do the hands-on workshop and you're actually in front of the hardware, we do that. The other thing we can get from this display are like watch tables that you have configured in your PLC code. Oops, went too far. So I can come here, I can do watch tables. I've got a watch table created for my, no, I have not. I thought I did. So tons of stuff here from the front display. All right, so let me share my screen again. But you know you're dealing with a 1500 PLC when you see that display screen. Compact Logics is an interesting PLC. On the one hand, you can do very small machines, very low-end compact logic with some onboard I/O, all the way up to very large processes. I mean, this Compact Logics has the same CPU in it as an L8 Control Logics. It's also very expensive. So it really depends on what Compact Logics we're talking about here as to what you compare on the Siemens side. You know, it could still be the 1500. That's a good look at that ET200SP CPU that we talked about. By the way, in Rockwell, we know if we see red, that's safety. In Siemens, if you see yellow, that's safety. The Micrologix 800. Anybody in here had any dealings with the Micrologix 800?
I just put 6 of them on my floor and I wish I hadn't.
Tell me more.
I went with the 800. And I've been an AV guy for 20 years. I went with the 800 price point and the fact that it was a 20 rung program with 6 inputs and 4 outputs. It was just perfect for the task. I just hate the damn things.
You got
So-
like components or
What's that?
do you not look at components or you like the?
Connected components is definitely what I don't like. I didn't like it years ago when they first launched it. I don't like it now.
So yeah, those of you that
It's from
don't
another
know,
company that they bought.
the Micrologix 800 programs with another software package called Connected Components Workbench. So you got to learn a new software package. It really doesn't look anything like anything you'd see in Logix Designer. I have to assume that Rockwell bought another company and that's how they got this. It's just so different than anything else they've done.
Yeah, so if you're a Rockwell house and you want to build on your Rockwell expertise or whatever and not assume learning curves, that's not the case.
Well,
No, that is not the case.
The part I really hate about it is they had beautiful PLCs with the 1400 and the 1500 and they got rid of them for that piece of crap.
I kind of had a different experience. I've enjoyed using them for many years now, to be honest. But I guess that's just me.
Do you do any data collection? Because they're real tricky with that.
Yeah, we do, but we're not, we haven't, we're not sending it to the cloud in most cases. It's more localized. But yeah, I've installed them on some pretty intricate machines. And we've had
So
good luck with them.
unfortunately, I can't really speak all of that knowledgeably about it. I've got a customer, Rockwell is phasing out the older Micrologix, the 1200s, the 11. In fact, most of them, I think all of them are gone except for the 1400. And so they're really pushing you towards this Micrologix 800. So I've got a customer that's got a bunch of old 1100s, I think, 1200s in their plant. And we're going to change them out. And I wanted to go Compact Logics. But the OEM that built the enclosures made the enclosures so tight that I couldn't fit a Compact Logics in there. The only thing that would fit in that space was an 800. So I am just now getting into CCW and the 800, and my initial experience is not good. I don't like the way it displays comments, both tags and run comments. There's a lot of things that I don't, there's a lot of addressing things that I don't like. And it's interesting to me that Rockwell put out this manual. It's for, okay, if you use Studio 5000, this is how you do it in CCW. It makes me laugh because that's exactly what we're doing today. If you do it like this in Studio 5000, this is the way you do it in TI Portal. And Rockwell's having to do the same thing. If you do it like this in Studio 5000, this is how you would do it in CCW. And you can't do safety there. They can't do remote I/O. you know, you have onboard IO, and then you've got expansion IO, and it's really based on the model of the 800 that you buy on how much expansion IO that you can do. On the 1200 side, and it's not even a fair comparison, the 1200 is a much more powerful processor than the 800. Very similar price point, which is interesting, but a lot more capability on the 1200 side. Yeah, you've got onboard IO. Yeah, you can do expansion IO, but then you can also do up to 16 IO remote IO racks, and you can also do safety there. And there are some bells and whistles that you have in here that you don't have here, and it programs with the same software as the 1500, so you don't have to learn a separate software package. PowerFlex drive, G120 drive. We talked about the panel views. The 5000 is the newer, not the newest, but the newer. That's where you've got the SVG graphics, programs with View Designer. That would be the unified comfort panel on the Siemens side, also SVG graphics. And again, not a fair comparison. The unified comfort panel is a much more powerful, capable HMI than the 5000. Very strong JavaScript programming language here on the unified that you just don't have over here. Out of the box, you can talk to a bunch of different PLCs, not just Siemens, but Rockwell, Mitsubishi, Modbus. Don't have to worry about, you know, third-party OPC servers or anything like that. You can't do that here. I'll be honest, even before I started programming Siemens, I never really liked the HMIs on the Rockwell side. We typically went, and we don't do a lot of machine control either. You know, usually we're doing full-blown SCADA systems, so you're using Wonderware or Factory Talk View SE or WinCC, one of those. So I have to admit, I don't do a lot on the smaller HMI side. Panel View Plus 7, not going anywhere, I don't think. I think Rockwell really wanted to phase them out when they introduced this, but the 5000 just never really got embraced, and so this guy's still there. The comfort panel, again, not a fair comparison. Comfort panel, you've got very strong VB scripting. Again, out of the box, you can talk to a lot of different PLC brands. You don't have to worry about third-party licensing or third-party OPC servers. Just a very capable HMI. Point IO, we've talked about on the Rockwell side, ET200 SPIO on the Siemens side. Obviously, Rockwell has a ton of IO families. Siemens does as well. I'm not going to bore you to tears with all the different IO families, but anything that Rockwell has, I have found some type of equivalent on the Siemens side, including like Armor Block. You know, Siemens has an equivalent. Ethernet IP is the main communication protocol for Rockwell devices. Profinet on the Siemens side. Profinet is an open Ethernet protocol. You don't have to use Siemens Ethernet switches. You don't have to use Siemens Profinet cable. You know, I've got the customer actually that standardized on this processor. Their IT folks made them use Cisco switches. We're running Profinet just fine on those Cisco switches. So the question I get sometimes is, if you put the biggest and baddest Rockwell PLC versus the biggest, baddest Siemens PLC, you let them fight it out in a death match, who wins? Well, it's a hard question to answer because what's important to you? Is it the amount of memory? Is it the amount of IO? Is it cost? Is it availability? Is it a corporate standard? Is it how much IO? So is it speed? It really depends on what it is that's most important to you. But I highlighted some of the more important things that we look at when I'm sizing or picking a processor. And one of them is the amount of memory. So on the Rockwell side, 40 meg versus 66 meg on the Siemens side. And so edge Siemens. And we've also got this rule of thumb here. So I was told years and years ago that a Siemens processor uses half the memory of a Rockwell processor. All right, now is that Siemens marketing spin? I didn't know, so I did a little bit of research. I'll show you the results here in the next slide. What about speed? All right, so just a very simple, normally open contact here, 2 nanoseconds on the Rockwell side, 1 on the Siemens side. We're talking nanoseconds here. They're both extremely fast. Siemens is a little bit faster, including just adding 2 real numbers together, 84 versus 6. So edge Siemens there. But then take a look at the amount of I/O. The Rockwell can do 128,000 bytes of I/O, 64,000 bytes on the Siemens side. So edge Rockwell. 300 nodes on the Rockwell side, 1,000 nodes on the Siemens side, edge Siemens. So again, there's some give and take there. It really depends. One of the big differentiators for me is the bells and whistles here. This is just a couple of them, but there is an integrated OPC UA server inside both the 1500 and the 1200 PLC. Yeah, hopefully you're familiar with OPC, but imagine you've got a third-party HMI application, and it needs to talk to your Siemens PLC. You know, in the old days, you'd go through some type of OPC server like a Kepware or a Matricon. You don't need to do that. The PLC itself can be an OPC UA server and serve that data up to anybody's OPC UA client. Now it's licensed separately, but it is a lot less expensive than a Kepware or a Matricon. And then the integrated web server. So Rockwell has a very rudimentary integrated web server, but the one inside of the Siemens PLC is just astounding, the amount of information you can get from it. And we'll see that a little bit later on today. I had a cost row up here. I took it out because I had list cost there because your multiplier is different than my multiplier. And does list cost really make sense to even compare? I didn't think so. I can say that I can get the Siemens processor for a couple of $1,000s cheaper than I can get the Rockwell. Has anybody else ever priced just in general Rockwell hardware versus Siemens hardware, and what's your experience?
I was working for an OEM. Our OEM price cut points in the US were phenomenal. Rockwell had made a real concerted effort to go after OEMs because little tin shack there, we're going through 50 processors a year and stuff as an OEM. However, when we started getting equipment from Brazil made for us, they couldn't get anywhere near the pricing we got. And when we tried to, get Rockwell to work it out with their counterparts in Brazil, it's like, well, it just doesn't apply. So there, the Siemens versus Rockwell cost was, the edge was Siemens.
Gotcha. Anybody else have experience with that? All right, I'll let you hash that out with your Rockwell and your Siemens distributors. But I know that I can get them several $1,000s cheaper, this guy over this guy. So what about that rule of thumb? Does a Siemens PLC really use half the memory of a Rockwell PLC? So I took advantage of a program that Siemens has. It's called Modernization Made Easy. We had a customer, they had a PLC 5, they wanted to convert it to a Siemens. And so I sent that PLC 5 project to Siemens. They converted it for me free to TI Portal. That program is called Modernization Made Easy. I'll show it to you real quick. So if you just Google Siemens Modernization Made Easy. So again, they'll take your PLC 5 logic, your slick logic, your micro logics, your control logics, your compact logics, and they will convert it for you free of charge. It says it right there, no charge code conversion. So we took advantage of that. I sent them this PLC 5 logic, let them convert it for me. And then I used the built-in migration tool inside of Studio 5000 to convert it. And here were the results. So the original PLC 5 program used around 6K of memory. The converted control logics ended up using 143K of memory. And the converted Siemens used right at 38K of memory. And so if you do that math, the Siemens used, you could really divide by 3.78. And that's how much Siemens memory used versus Rockwell. So that divide by 2 is actually a pretty conservative rule of thumb. Now, would that always be the case? I have no idea. But in this case, yeah, that rule of thumb held. And by the way, those free of charge conversion services, they're actually very good. Like we didn't have to make, I don't think we had to make any changes in the PLC 5 logic. I think it pretty much got it 100% of the way there. And PLC5s, slicks, Micrologics, they've got that very known data structure with data files, N7, F8. Those convert very easily. When you get into control logics and compact logics, those become a little more difficult when you got UDTs of UDTs and AOIs calling AOIs. They may get you 50% of the way there. They may get you 75% of the way there. And then if you've got any messaging between PLCs, that you'd have to do by hand. Now, there is a way to have a Siemens PLC message a Rockwell PLC, but you would need to do that conversion yourself. But take advantage of that Siemens modernization made easy. Again, we know that there's a ton of Rockwell processors that are obsolete. Why not see what Siemens can do for you there? Let them convert.
How does Siemens compare with that obsolescence? Because again, like you said, Allen Bradley has a known history of obsoleting one thing after another. How in their new series, they already have some stuff obsolete. They just launched it 2-3 years ago. So
yeah, that sort of surprised me about Rockwell, because the PLC5, it felt like it was around forever.
As it was.
And the slicks too. And even some of the early micrologics, but then it seems like the control logics and the compact logics, and I really love that L35E compact logics. But it just didn't seem like it was around very long, and then it was gone. I have not seen that with Siemens. So with Siemens and TI Portal and this whole hardware line, the 1500, the 1200, the ET200 SP, they started that from the ground up. It's all brand new from the ground, including TI Portal. They started from scratch. So what that would have been 2010, 2011, somewhere around there that it first got released.
Yeah.
So they built all of this with some of the newer technology in mind, whereas control logics, that dates back to what, 95, 96. So it's pretty long in the tooth. And so how much can you do? How much change can you make to Studio 5000 without affecting the hardware underneath? Or how much change can you make to the hardware and not affect the software on top of it? And so, at some point, Rockwell's going to have to do something. The L8 processor, they put that Ethernet port on board the processor just because they had bottlenecked themselves on the backplane speed. And so the only way they were going to get to gig update rates on their I/O was to put a Ethernet port on the front of the processor. So that's why you see that L8 now with the Ethernet port on board. But they don't want to make a change to the backplane, because as soon as you do that, you're opening up the door. You got to change your I/O modules. I mean, there's a lot that touches. So that's one of the good things that Siemens did, is they bit the bullet back in 2010, 2011, whenever it was, and they said, okay, we're going to start from the ground up. Whole new hardware platform, whole new software platform. And was it rocky at the beginning? Absolutely, it was with any new release. Version 10 of TI Portal, version 11, version 12. There was some issues there. But starting at version 13, Service Pack 1, man, things were just stable, and we really got a great hardware and software platform. So I guess the long way to answer your question there is, because all these hardware platforms are so new, we don't see that obsolescence like we see on the Rockwell side. The only difference though is the HMI. They did go, and when you think about operating systems in computers and computers themselves and how quickly those change from year to year to year, to keep up with cybersecurity and all that stuff, the HMIs are a little bit more highly affected than the PLCs. So I think that's why Siemens sort of went with that whole new line of unified comfort panels, is to keep up with all those changes that are going on in the PC world. But the PLC world, we're a little bit more, I would say, slow to change. But again, if you want to take advantage of it, Google this modernization made easy. Give it a try, see what happens. All right, so let's program. And we're going to start with the IEC 61131-3 regulation. I'm sure you know this one by heart. You know it, you love it. But if you don't know it, to reduce complexity for the users of PLCs, that's you and me. That's why they put together this IEC regulation. My first exposure to Siemens, again, probably would have been 94, 95. We were programming a bunch of PLC 580Es in this textile facility, but in the back of the plant, there was a baler that had come from Germany that had a Siemens S5 PLC on it. Anybody in there seen Siemens S5 code?
Yes.
And your thoughts?
Comparable to its competitors at the time.
See, I found it so well, and again, it was all programmed in statement lists. So I looked at that S5 code and I thought, man, that is so complicated. I'm not going to program Siemens. And I didn't. For the next 20 years, I didn't touch a Siemens PLC because I thought it was complex. I thought it was too complicated. I skipped the whole step 7 classic phase, and I didn't touch Siemens again until TIA Portal. Well, the IEC sort of steps in and says, you know what, we're going to make it easier for you, Ron. We're going to make it easier for you to go from a Rockwell to a Siemens to a Modicon to a Mitsubishi. Well, the first question is, well, just because the IEC releases this standard, Rockwell can ignore it. Siemens can ignore it. Well, they both care because they both release manuals on how they are IEC compliant. Here's the Logix 5000 IEC compliance, and here's the Step 7 compliance. Because they want to say, hey, we're not complex. Look at us. We're IEC compliant. So what does the IEC have in it that makes our lives easier as PLC users? Well, among other things, the IEC says you should have these native data types. So Booleans, counters, doubles, integers, real, small, string, timer, date, time, and time. We should be able to create our own complex user-defined data types. And we should be able to address arrays. Yep, we can do both of those, or all of those, in both Rockwell and Portal. Check, good. The IEC said you should also be able to use these programming languages: ladder, function block, SFCs, structure text, and instruction list. So Studio 5000 does not have an instruction list programming language. Siemens has something called statement list. Anybody in here seen statement list?
Yes.
And?
Written and commented in German. It was wonderful. It's basically, in my mind, it was assembly language.
Exactly. If you've never seen assembly language, you've never seen statement list, this is what it looks like. Very low level code, like you said, assembly level, very simple instruction set. I find this unreadable only because I just don't use statement lists very often. I teach this class sometimes with a Siemens engineer as sort of the guy I'm teaching with, and he can read it immediately because he did a lot of statement list programming. But if you don't do it very often, this is pretty hard to read. So it doesn't hurt my feelings any that Rockwell doesn't have a statement list programming language. Let me ask you this question. How often do you guys get to use all of these programming languages, or do you typically only get to use ladder?
Structured text. We use structured text for mapping.
So you get to use structured text for mapping?
That's for the most part all we use it for.
Okay. Everybody else mainly you live up here?
Would say all of them, ladder logic being the most common.
Yeah. Okay. Yep. So I've got customers that, they obviously they know and they love ladder logic. They begrudgingly let me do function block diagrams, mainly for PID loops, totalizers, discrete two-state devices, any kind of continuous flow stuff. FBDs are very good for that. I've got some process customers, not so much in Portal, but in PCS7, where we use SFCs a lot. Think a batching type process. I love structured text. I just don't get to use it very often. But mainly my customers really want me to live here. This is what they know. This is what their guys know. And so when a machine goes down at 2 o'clock in the morning, when all machines go down, they know ladder logic. They can get online with the PLC. They can look at that ladder logic. It's a very graphical, intuitive programming language. They can get that machine up and going very quickly. And I understand that. And then finally, the IEC says you should address your inputs with I's and your outputs with Q's. That is why Siemens refers to digital output modules as DQs and analogs as AQs. And why do you think the IEC said that? Why do you think they want to use a Q instead of an O?
The O and the 0 look the same.
Exactly, you nailed it. An O and a 0 look a lot alike. Hey, let's not cause any confusion. Let's use a Q. And Studio really hasn't embraced that.
Ones don't look similar.
Yeah, I was thinking the same shit.
What's that?
It's a good thing the I's and the ones don't look similar.
An I, a 1, and a lowercase l look a lot alike, sure. Well, the IEC is not perfect.
I also got to think of the way the Germans draw their ones.
How do they draw them?
It looks like a greater than symbol almost on its side. Your top section comes down a lot further.
Oh,
And
really?
it's more up to the point, but that's why they put the line through the sevens to
See,
differentiate.
I always, when I'm writing, I always put a line through my 0.
Yeah. So the Germans, their ones and sevens look very similar. That's why they put the little line through the long shaft of the 7. Yeah. Right. Yeah.
Okay. I don't guess I ever really noticed that. Rockwell didn't embrace that completely. They've got this name slot I member and the name slot O member. Doesn't CCW, isn't the done bit out of the timer a Q?
Yes.
Yes.
Okay, yeah, I thought so. But Portal, %I, %Q, we've seen that already. All right, so let's start with the UDT, user-defined data type. So let's say you're programming a valve and you're doing it inside of a SLIC or a Micrologics or a PLC5. In the old days, the way we would do that, all right, so we've got this valve, we write the logic for the valve to control and monitor it from the HMI, and let's say there's 10 rungs of logic associated with that valve. We'd get that valve up and working, and then every time they would add another valve, we would copy those 10 rungs of logic, we'd paste them, we'd change all the addresses, there's valve number 2. You add another valve, you copy and paste that logic, you change all the addresses, there's valve number 3. So if you had 50 valves out there in your logic, you had 50 rungs of logic, or 500 rungs of logic, sorry. Well, the problem is, let's say there's a bug that you uncover, or they want to add some capability to the valve, to every valve. Well, then you got to go touch all 500 rungs of logic. Wouldn't it be easier if we just wrote that logic one time, reused it over and over again for every valve, and then if they needed to make a change, we change it in one place and it automatically updates every valve. All right, that's where the add-on instruction came in. Likewise, if we're going to monitor and control that valve from the HMI, and let's say there's 1, 2, 3, 4, around 15 or so tags that we want to be able to read and write from the HMI. In the old days, we would create those tags for every valve, copy and paste them, change the address, copy and paste, change the address. So the problem is, operations comes and says, you know what? We want to monitor torque feedback on every valve. Go and add torque feedback to every valve. Well, we would have to go touch 500 rungs of logic and then come to the HMI, create 500 or 50, however many valves we got, tags for torque feedback. What the UDT allows us to do is we could now come and add torque feedback somewhere here in the UDT, and then it would automatically add that to every valve that used this user-defined type. All right, efficient engineering. Let's do it once, and then it's applied to everything. That's object-oriented programming. And so for a valve, this is the UDT that the HMI uses to monitor and control the valve. And it's got things that you would expect for a valve. From the HMI, we can request the valve go to auto, we can request it go to manual, and then we get feedback saying, yep, I made it to auto, or yep, I made it to manual. If it's in manual, the operator can request the valve to open or request the valve to close from the HMI. Here's confirmation that it made the manual open. The actual output of the valve, an interlock, like the steam valve, valve 11. Maybe you don't want to let that valve open if you got a high tank temperature. So you interlock the valve, don't let it open. The alarm, this is actually an integer instead of a Boolean. Maybe we got a failed to open, a failed to close, both opened and closed. So 3 different alarms there. Status, also an integer. We're moving, we're opened, we're closed, we're faulted. 4 different states there. And then I also like to throw the name and the description of the valve for the HMI to read. Both of those are strings. Once we create the data type, we then have to go create valves, tags for every valve. Now in this, we've got valve 11, steam valve, and valve 12, the discharge valve. Where do I create tags in Rockwell? Well, I can either create them in controller tags or I can create them in program tags or local tags. So here I am in controller tags. There's my valve 11. My naming convention, I like to throw HMI in front of it if it's something my HMI is using. So there's the steam valve. I use the UDT that we just looked at. And so, of course, I get all those member variables, auto, manual, blah, 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 all the way down. And then I went ahead and filled in the name and the description. Right below it is valve 12, uses the same UDT. So later, when they add valve 13, I create a valve 13 tag, use the same UDT. Valve 14, valve 15, valve 55, valve 99, all use the same UDT. So now when operation says, hey, I need you to add torque feedback to every valve. I come in here, I add torque feedback to the UDT. It automatically adds it to 11, 12, 17, 22, 66, 99. Really is a huge time saver. All right, so let's go look at that inside of TI Portal. Where do we create our own user-defined types and where do we go and create tags? All right, let's jump back over to TI Portal. If you haven't done so, click the Save Project icon with the antiquated floppy disk there that no one uses anymore. That's a 3.5-inch floppy, by the way, for those that don't know it. I got to show you a meme. This made me laugh and cry at the same time. That's just brutal. Eventually, they're going to have to save that icon because nobody's going to know what the heck that thing is. Anyway, so we save the project. So in Rockwell, where we create our data types is under Assets, User-Defined Data Types. In Siemens, we've got a dedicated folder called PLC Data Types. So expand that folder right there. PLC Data Types. Underneath, you can see we've got 5 different data types. I've got a UDT analog interface. That's what gives me my scaling and my alarming for temperature transmitter, a level transmitter, or any analog I ever had. Fixed speed motor interface. The sequence interface, that gives me the step number and the elapsed time and the start and the stop and the step buttons and all that. Solenoid valve interface, that's the one we just looked at in Rockwell. And then I've also got a UDT for the variable speed motor. But these are the UDTs that give my HMI all the necessary tags to monitor these different devices. Now you'll see that some of them have this little black top hat or earmark on them. That just lets me know that that particular data type is tied to a type in the project library. Hopefully we can get to that this afternoon. But for now, we're just going to ignore it. So just ignore that little black top hat. Hopefully we can get there this afternoon. But we looked at the solenoid valve interface in Rockwell. So let's double click right here, solenoid valve interface, and let's compare it to what we just saw in Rockwell. So double click the UDT solenoid valve interface. So under PLC data types, we did a double click right there. Again, ignore the big yellow header up here. Again, it's letting us know that it's tied to a type in the library. Hopefully we can get to that this afternoon. But more importantly, look at the member variables here. They are exactly what they look like in Rockwell. Auto request, manual request, all the way down. Notice the Booleans, all the way down to name and description being strings. And that is because the IEC said you shall have a Boolean data type. You shall have an integer. You shall have a string. Oh, and by the way, you're going to be able to wrap all those up into your own user-defined data type. All right, so Rockwell is embracing that IEC standard, as is Siemens. Again, we've got some additional columns out here. I'm going to go over those a little bit later. All right, so the data type looks exactly the same. Now we know we need to go create a tag for valve 11, the steam valve, and valve 12, the discharge valve, using this UDT. Well, in Rockwell, we would have gone to controller tags to do that. So where do I go and create tags in Siemens? And your gut instinct is, well, heck, there's a folder right here called PLC tags. Surely it's there. Remember, PLC tags is only IO. That's our %I's and %Q's. This is not where we're going to go and create tags that we're going to use for our HMI and for our logic. PLC tags are IO tags. All right, so then where do we go to create valve 11 and valve 12 that our HMI can look at? There's a folder called program blocks right here. Program blocks is where you're going to go find all of your logic and all of your tags other than those IO tags that we talked about. But all of your logic and all of the tags will be found in program blocks. Now, that's not necessarily true if you use software units, but that's outside the scope of this class. So, all right, so underneath this program blocks folder, we got two purple blocks here, cyclic and main. We're going to ignore those for right now. We're going to come back to those. But then we've got this block here called glob controller tags. All right, this is known as a global data block. And I named it controller tags just to let you guys know that a global data block is the same thing as controller tags in Rockwell. Now, the difference is I can create as many of these global data blocks as I want, and I can name them anything I want. And that really allows me to organize my tags down into more manageable pieces. And I typically would not name it controller tags. That is a very Rockwell term. All my Siemens friends would laugh at me if I did that. All right, so typically, you're going to name these global data blocks. Think of if you've got a process, a different process section. Okay, this is tags for the mix tank. These are tags for the holding tank. These are tags for the sequence. And I throw glob in front of it just as a naming convention to let me know that this is a global data block. So glob for global. But let's open this guy up. Let's take a look, see what we got in there. So double click that global data block. Remember, we're looking for the HMI tags for valve 11, the steam valve, and valve 12, the discharge valve, using this UDT. All right, so let's open up this global data block named controller tags. All right, so we did a double click right there. All right, notice right off the bat there, the top two tags, HMI SV11, same name as we saw in Rockwell, data type, exact same UDT that we saw in Rockwell. Notice my naming convention for my data types, I always precede it with UDT. It lets me know that it's one that I created. If we expand that HMI tag, as you would expect, you see all the member variables, just like we saw in Rockwell, auto, manual, all the way down to the name and the description. Right below it, there's valve 12, using the same UDT. So this is the IEC 61131 doing work for us. The data types match. Data, you know, the not only the data native data types, but our ability to create our own data types and the way we name them and the way that they are shown. Very easy to go between Studio 5000 and Portal. All right, so let's create our own data type for a generic level switch. And we're going to use this data type to allow our HMI to monitor every level switch we're ever going to create. All right, so underneath PLC data types, underneath this folder right here, double click add new data type. So under PLC data types folder, double click add new data type. We're going to create us a new data type for a level switch. See if I can zoom and get all this in one picture here. There we go. So under PLC data types, I did a double click, add new data type. Notice it added it, gave it a terrible name, user data type 1. We're going to change that. All right, so what member variables do we need here that we want to monitor from our HMI for any level switch? Well, maybe we want to be able to set or at least display whether the level switch is wired normally open or normally closed. All right, so I'm going to type in these different member variables and then I'll zoom in so you can see it. So wired normally closed. Of course, we want to know whether it's an alarm or not. And maybe we want to be able to set the debounce time from the operator interface. You know, if the level's right at the level switch, alarm may chatter, upsets the operator. You never want an upset operator. So maybe we want to debounce that signal a little bit. All right, so let me zoom in here so you can see this. Let me shrink down some of these columns so maybe I can zoom in and you can see everything. There we go. All right, so create these 3 member variables. Make sure you pay attention to this data type. Of course, you want to put in a good comment. So go ahead and type those in. Looks like everybody's pretty much got those typed in. All right, so obviously I don't like this name right here. Horrible. So let's rename it. So out here in the project tree, you can right click it and do a rename. You can select it, hit F2, or you can just slow click it sort of in the Windows fashion and rename it, which is what I typically do. And I'm going to name it UDT level switch interface. So rename it to this. So now we need to go and we need to create tags for every level switch using this new data type we just created. Now they've only asked us to add level switch 13 today, but we know next week it'll be 15 and next week it'll be 16 and then eventually we're going to be up to 55 and then 99. All right, but today we only need to add level switch 13. All right, well, where do we create tags? Again, your gut instinct is, well, surely right here, there's a folder right there called PLC tags. Remember, the only thing we put here is IO, aliases, to use Rockwell terms. So instead, we're going to create tags in global data blocks. And remember, we have a global data block already created called controller tags. Terrible name. And actually, we already have it open. I didn't show this area earlier, but down below, we have this area called the editor bar. And it just keeps up with all the different windows that you have open. And you can see that glob controller tags is still open. It gives you quick navigation to those open windows. So let's return to glob controller tags by clicking it down here in the editor bar. And you will see as we go along today, this editor bar gets pretty cluttered up because we get window after window after window open, but we'll worry about that later. We're returning to glob controller tags. And I want to come down to the very bottom, very last tag here is this HMI hold tank request. That's that button in the bottom right-hand corner that allows the sequence to move to discharge mode. But I want to add a new tag for level switch 13. All right, so I can right-click that last tag, and I can either do an insert row, which will create the tag or the empty row above the cursor, or I can do add row, and it creates the tag below the cursor. Doesn't really matter. I'm going to do an add row there. Right-click, add row. And I'm going to name it HMI underscore LSH13 and use our new UDT that we just created. And of course, I'm going to put in a good comment, mixed tank high level switch. Can't quite get it all on one page, but everybody create that tag right there. And make sure you put in a good comment out there, mixed tank high level switch.
It's closed. Yeah. It's weird. I have any public interface.
Oh, you pulled.
She do the box.
Yeah, can find it.
Crawl it. Yeah, I got it.
All good?
Yeah, I think we're good here.
All right, great. So another quick term to remember here. In Rockwell, we call them a user-defined data type. In Siemens, we call them a PLC data type. Other than that, they're pretty interchangeable. And so there's some interesting things here. We know in Rockwell to change a UDT if we wanted to come in and add a member variable, we know we have to do that offline. That means download, that means stop. So, you know, a lot of times what we'll do is we'll just add spare 1, spare 2, spare 3, or something like that in the UDT so that we can expand it. It doesn't allow us, you know, you're not really taking advantage of good naming there, but at least allows you to expand those tags without stopping the PLC. You know, a lot of my customers are 24/7. You know, they may shut down between Christmas and New Year's, and I really don't want to be there then. So we got a similar issue in Siemens. In Siemens, we can modify UDTs without stopping the processor, but any tag that uses that UDT gets reset to their default values. And we're going to see that a little bit later on today when we get online with the PLC, but it's a lot like putting the processor in stop mode. So we got some of the same limitations. So I also, even in Siemens in a UDT, I'll put in some spare member variables just in case I need to expand. All right, so we did all of that. All right, here we go. How are we doing on time? So it's 11:30 there. Okay. So this will be the biggest difference, hurdle, whatever you want to call it, between bouncing back and forth between Rockwell and Siemens, and that's organization. The IEC is fairly generic when it talks about project organization. I think they refer to process object units and different things. And so you get a very large variability between Rockwell and Siemens and GE and Monicon on how things are organized. We know that Rockwell went with the task, programs, and routines structure. So let's take those one by one. What is a task? Well, a task is something that's automatically executed by the CPU. There are 3 different kinds. There's a continuous. There can only be one of those. You can do a periodic task, or you can do event tasks. But only one is automatically created for us, and that's the main task, and it is the continuous task. That one automatically gets created. Any other task that we want to add, like this periodic task, we, the developer, have to add that. Can someone give me a good example of when you have used a periodic task? Why would you use a periodic task?
Basically wanted to slow down the process and checking of IO or something like that, like a particular IO point.
Exactly. Anything you want to slow down. It doesn't need to happen every scan. One of the things that I've used it for a lot is PID loops. You know, PID loops behave a lot better if they're executed at a known rate. You know, main task is variable, its scan rate. But this periodic task will actually interrupt the main task to execute. So if you say 100 milliseconds, it's going to execute every 100 milliseconds. We do not write logic in a task. You cannot write logic in a task. Instead, a task is made up of programs. And you can have up to 100 programs per task. And it's up to you, the developer, to decide how many programs you're going to have and when they're going to be executed. All right, so what's a program then? Well, a program is executed anytime the parent task is executed. So in this picture, main program gets called when main task gets executed. And main program is the only program that automatically gets created for me. Any other programs I have to create. We know that each program has its own local set of tags as well. We do not write logic in a program. We can't. No logic is written there. Instead, a program is made up of routines. And you can have as many routines in a program as you want until you run out of PLC memory. And you can name them anything you want, and you decide when they get executed. The only routine that gets called for us automatically and created for us automatically is main routine. So main task calls main program calls main routine. Those are the only 3 things that automatically get created for us. Now we could write all of our logic right there in main routine. If you do that, someone does not like you. That would be a lot of logic in one routine. Instead, what do? We create additional routines that allows us to organize our logic into more meaningful pieces. It allows somebody coming in behind us or future us to go and find something very quickly. So if it's your first day on the job and they say, hey, the mixed tank sequence is stuck in step 6, can you tell me why? Well, this is a good place to start, as opposed to have to wade through 20,000 rungs of logic here. Do these routines automatically get called for me? Somebody's got to answer. Do these routines automatically get called for me?
Getting a lot of no's.
No. How do we do it?
JSR.
Yeah, you got to add JSR here to the main routine. And typically that's all we see in main routine is a bunch of JSRs. Now I've gotten lazy before and thrown some diagnostic logic in there, maybe some communication stuff, but by and large, JSRs are what we find in main routine. All right, and then we've already talked about tags. We know about controller tags, and we also know about each program has its own set of local tags. All right, so how does that compare to a TI portal project PLC layout? Well, the good news is there's only 4 programming blocks. How difficult can it be? All right, so at the very top, we've got the organization block, the purple one, and you'll hear Siemens programmers just shorten that to an OB. So what is an OB or an organization block? That's a program block that's automatically executed by the CPU. Hey, well, wait, that sounds familiar. A task is automatically executed by the CPU. Is an organization block the same thing as a task? Yeah, continuous tasks, periodic tasks, even fault routines. Anything that's automatically called by the PLC is an organization block in Siemens. Now, the difference is we actually write logic in an OB. We don't write logic in a task. We can, and have to write logic in an OB. All right, but so far so good. If I'm thinking task in Rockwell, I'm going to think organization block in Siemens. Function block, the blue one, an FB. It's a program block that has defined inputs, in-outs, outputs, and has local memory. And you can write logic in any of the available programming languages. All right, well, that sounds like an add-on instruction. Yeah, AOIs and routines in Rockwell could be function blocks in Siemens. All right, so far so good. If I'm thinking task, I'm going to think organization block. And if I'm thinking AOI or routine, I'm going to think function block. All right, easy enough. Now, why do I need this third one, the function? So it's a program block that has defined inputs, in-outs, and outputs, but no local memory. Function block has local memory. The function does not have local memory. Okay, more on that later. You can write logic in any of the available programming languages. Add-on instructions and routines in Rockwell could be functions in Siemens. Now, wait a minute. You just said function blocks could be routines or AOIs, and now you're saying functions can be. Which is it? Yes. And in a one-day virtual workshop, I'm not going to expect you to leave here and know when you can choose a function block and when you can choose a function. But I'm going to give you an easy out. If you always choose a function block, it will always work. So if you're sitting there thinking, you know what, in Rockwell, I would create an AOI here, choose function block. Or if you're sitting there thinking, you know what, in Rockwell, I would create an intermediate routine here to organize my logic into more manageable pieces, choose a function block. It'll always work. Okay, well, why are you saying that? Well, remember, a function block has local memory and a function does not have local memory. So there are times where you can get by where you don't need that local memory. But even if you create a function block and don't use the local memory, it's still going to work. Now, I'm going to explain that in a lot more detail as we go on. But again, one thing to remember, we're going to lean heavily on the function block and its local memory. It's rare that I create a function. All right, so if you leave here today and for the next 2 or 3 years you're writing logic and you never use a function, that's okay. Because if you always just do nothing but OBs and function blocks, it's always going to work. All right, more on that later. Data block. Now we've already talked about the global data block. Remember, it's the same thing as controller tags. It's just a place to go and create tags that are global to the entire project. Remember, it's different than controller tags in that I can create as many as I want and name them anything I want. It allows me to organize my tags a lot better. That's one of my gripes with controller tags. You know, if you open up controller tags in a Rockwell PLC, there could be thousands, if not tens of thousands of tags in there. It's hard to find anything. In Siemens, I can actually create, and I do create a bunch of different global data blocks and just have a handful of tags in each one of them. It allows me to find tags a lot quicker. Here's a great term to remember. Now, you'll have a copy of this PowerPoint later, but remember this one. This is a great rule of thumb for you as you move forward. In Rockwell, the continuous task is the same thing as the program cycle OB in Siemens. Now, the difference is we can't write logic in a task, but we do write logic in the program cycle OB. Also, just like in Rockwell, this guy is automatically created for us. In Siemens, this guy is automatically created for us. Anything else, we have to create. All right, periodic task, cyclic organization block. A fault routine. Remember, a fault routine gets automatically called by the Rockwell PLC. Now, we have to create it and define it. It's not automatically created for us. In Siemens, that would be the programming error organization block. Same thing. It's not automatically there. We would have to create it. I'll show you that in a second. A main routine, program cycle OB. Notice we got program cycle OB twice. That's because the program cycle organization block rolls up main task, main program, main routine, all in one block. AOI, function block or function, we're going to lean real heavily on the big one, the function block. A routine, function block or function, we're going to lean real heavily on the big one, function block. Because remember, it has local memory that we may or may not need. But it's better to have it and not need it than to need it and not have it. So we're going to lean heavily on the function block. All right, more on that later. Controller tags, again, global data block. So we just created that tag a second ago, HMI LSH13. What are the tag naming rules? In Studio 5000, we know that we can create tags in either the controller scope or the program scope. We've talked about aliases, 40 character limit on your tag names. Don't do that. That's a lot of characters to put in a tag name. Again, somebody's mad at you if you've done that. They are not case sensitive. No special characters. In Rockwell, we can use numbers, letters, and underscores only. And there have been times I wanted to throw in a number sign or a percent sign in my tag name. Can't do that in Rockwell. And we know that tags can only be defined in controller tags or program tags. In Portal, all tags are global. We don't have that program structure like you do in Rockwell. There is no idea of these local tag names. We've talked about alias tags. They're called PLC tags. 128 character limit. Please don't do that. They are not case sensitive, just like in Rockwell. Special characters are allowed. You can use any character on your keyboard except for the quotation marks. So yeah, you can use the number sign, you can use the percent sign, you can even use spaces in your tag names. I don't recommend using spaces in your tag names. That becomes very complicated later on. Is that mix space tank or mix tank or? By the way, I keep talking about this best practices. Let me show you a manual that I recommend you downloading. It is called the TIA Portal Programming Style Guide. This guy right here. Programming Style Guide. It gives you some great tips on how to name things, how to organize things. So I mentioned earlier today about using camel casing. All right, so if I just do a search real quick on camel. So it says use camel casing for code elements such as variables, PLC data types, structures, PLC tags, parameters. And it says the use of separators like hyphen or underscores are not permitted. So that's sort of confusing when it says that they're not permitted. The programming software allows it, but if you follow these rules inside this programming style guide wouldn't allow it. And what's cool about this programming style guide, there's an add-on to TI Portal called the Test Suite, where it'll actually go and analyze code to make sure that it follows the style guide, and it'll identify anywhere that the style guide is not followed. And you can even make up your own style guide. So you can start with this as a base, because there are things in here that I don't agree with. And so I've sort of created my own style guide to the side of this. Good starting point, but the test suite software is good. Like if you're getting equipment in from an OEM and you've given them your style guide and you want to make sure they followed it, you can use test suite. It'll go and analyze their code and it'll highlight anywhere that it did not follow the style guide. All right, so recommend this one. Again, it talks about how to name things, how to organize things. It's a great starting point just to figure out, how do I even get started here? You know, how do I name things? How do I organize things? This is a great manual. All right, so that's the rules on tag naming. So let's take a look at that global data block in a little bit more detail. How am I doing on time? 15 minutes, perfect. All right. So you should still have this global data block, glob controller tags open. If you don't, it should be down here in your editor bar, glob controller tags. If you accidentally closed it, remember you can find it under program blocks and just double click glob controller tags. So we've already been introduced to some of this global data block. Of course, the name and the data type, self-explanatory. That's the same as what you have inside of controller tags in Rockwell. But a big difference is the start value column. Hugely different than what you're used to in Rockwell. So let's say we're running this mixed tank sequence in a Rockwell PLC. We're in step 6, which is the waiting for the temperature to come up to 90 degrees. So the agitator's running, the steam valve is opening, closing as it needs to get up to that 90-degree mark. And we lose power to the plant. A 18-wheeler hits a transformer, shuts down power to the plant. We're out of power for a week. When power is restored, the ControlLogix PLC comes up, goes into run mode. It picks up where it left off. So it'll pick right up from where it left off in step 6 of the sequence. Now may have drained the tank. There's nothing in there. We may not want the agitator to start. We may want that sequence to reset to step 1 as opposed to pick up where it left off. And if we want that, then we need to use that first scan bit that we talked about earlier today. You know, first scan of the PLC, take the sequence from step 6 or just force it to step 1 where everything is shut down. That is not the way a Siemens PLC works. The way a Siemens PLC works is if we lose power to the plant, it gets restored and power comes back and the PLC goes from stop to run. Every tag is going to be set to its start value. Every tag in every global data block set to its start value. So let's go see what the mixed tank sequence is going to do. Come down and find the HMI underscore sequence mixed tank tag and expand it. This guy right here. So expand that tag. And the logic uses this member variable, step number, to keep up with what step we're in. Notice the step number start value here. It's a 1. So when this PLC goes from stop to run, like after a power outage, it's going to go, the sequence is going to be reset to step 1. We don't have to do anything with the first scan bit. It's automatically going to happen. Well, what if we don't want that? What if we want the sequence to pick up where it left off? That is where the retain column comes in. So if you select a node for a UDT, you have to select it at the top level up here. If you select the retain checkbox, anytime that the tag's value gets changed, the value changes, it gets written to a non-volatile area, a retentive area inside of PLC memory. So now when the PLC goes from stop to run, like after a power outage, it says, oh, I'm going to set this tag's value to its start value. Oh, wait, retain is checked. Let me see what the last value was that I have in my retained memory. And I'm going to start the tag from there instead. And you don't want to just automatically go and set that retain checkbox for every tag, because there are times where you're not going to want that tag to be remembered. You don't want it to pick up where it left off. Can someone give me or think of a good example of where you want a tag's value to pick up where it left off before a power outage? Give me a good example of where you'd want to use that retain checkbox.
Layer pusher,
Say again, I'm sorry.
layer pusher on a palletizer.
Ah, great example. Yes. You know, if you've got a palletizer and you're counting layers, it needs to remember where it left off, because if it goes back to layer 1, you're going to start knocking bags of stuff all over the place. Great example. Anybody else think of another example? One more. So where I have used it, I did a project for a port over in Gulfport, Mississippi. It's a big ore handling facility, but they do all their preventive maintenance on all of their conveyor motors based on the runtime hours. And if all the runtime hours reset to 0 after every power outage, and the port loses power all the time, preventive maintenance is not getting done like it should. Right? So I need to remember how many runtime hours I have after a power outage. I can't let that reset to 0. Any questions on the combination of start value and retain? Because that is quite a bit different than a Rockwell PLC.
What happens when you program download?
So if you do a program download, because what we think about in Rockwell, because when we do an upload in Rockwell, it saves all the tag values, and so when we turn around and do a download, it downloads the tag values. We don't do that here. The values that are running inside the PLC are not saved when we do an upload from the PLC. Now there are some things that we can do to grab those values, but they don't get downloaded like you do in a Rockwell PLC. Now there are some buttons up here that we'll see that we can approximate what happens in Rockwell. And I'm going to go through these buttons when we get online with the PLC. Notice they're grayed out because they only make sense if you're online with the PLC. But in general, when you do a download to a PLC, let me start from the other side of that. When you do an upload from a PLC, you don't get the online values. Those don't come along with the data block. And so when you do a download to a PLC, it doesn't have any online values saved. So the PLC goes from stop to run, every tag gets set to its start value. If retain is checked, it doesn't have anything retained because it's a brand new PLC. So again, everything's going to get set to its start value. Great question. Downloading is completely different in Siemens versus Rockwell.
When you retain the HMI sequence, is there any way to not retain all of it? It is grayed out for me once you retain it.
Yeah, so no, you have to retain at the UDT level. And so if there are pieces of that that you don't want to retain, then you would need to split that up into separate UDTs. But in this case, I'm okay with retaining everything. Because, we're not talking about a whole lot here. And yeah, there's nothing here that I wouldn't necessarily want to retain anyway. So I guess to answer your question, if there's something that you don't want to retain inside of a UDT, then you would really split that up into two separate UDTs. Because I don't even think at the UDT level you can, retain is not even part of the UDT. So yeah, that's the way you would do it. Great question. Any other questions on start value and retain? All right, so let's finish the rest of these columns and then we'll break for lunch. The next column over is this accessible from HMI, OPCUA, and web interface. So do you want the HMI to be able to read the value of this tag? Do you want the OPCUA server? We talked about that earlier. Do you want an OPCUA client to be able to read the value of this tag? And I also talked about the web server. The web server, again, gives you a ton of information from the PLC. Some of the information that you can get is the tags value, but only if you selected this checkbox. Next column over is writable from those same interfaces. Do you want to be able to change the value of those tags from those interfaces? Visible in HMI engineering. When you're developing your operator interface, and let's say you drop an analog display on the screen and you want to browse to the tag in the PLC. If you don't select this checkbox, then this tag is hidden from your HMI development. This is kind of helpful if, let's say you're developing the PLC logic and you've got somebody else that's developing the HMI and you really don't trust that person. So you don't want them to even be able to see the existence of this tag. You can deselect that, and when he's doing his HMI development and is browsing, he can't even see this tag. You've got trust issues, but you know what? It may be well-deserved for the HMI developer. And then finally, the set point column. This one is sort of interesting. It is a reminder for you, the developer, that when you are commissioning your logic, to go back and double check what you have set for the start value. All right, so let me give you a good example here. How about the one we just created? So remember that we created this HMI LSH13, and by default, its debounce time is 100 milliseconds. All right, well, we're guessing at that. Depending on the tank size and how quick that level changes, that 100 milliseconds may not be sufficient. So when we're developing at our desk, we can click this set point checkbox right here. And that's a reminder that when we go to commissioning, we need to double check this debounce time based on actual field conditions. Okay, 100 milliseconds isn't enough. I really need that to be a full second or 5 seconds. So as you're commissioning and you check and you verify these start values are good, you deselect that set point. That lets you know it's done. It's just a checklist for you as you go through your commissioning steps. That set point checkbox can also be used as a filter for this button and this button, but we'll talk about those when we get online with the PLC. Any questions on the set point checkbox? And if you hover over, by the way, the word set point, it'll tell you. Indicates whether it is likely that the value of this tag will have to be adjusted during commissioning. And when they talk about value, they mean the start value. Supervision. This allows you to automatically create alarms, think process alarms, without writing any code. So if we wanted to set a high temperature alarm or a high level alarm, we could actually create a supervision and not have to write any logic for it. It's something called ProDiag, and it's an add-on license to both your PLC and your HMI. We cover it in the 2-day workshop. I had to cut something for a 1-day workshop, so it got cut. But imagine being able to set alarms without writing any logic. That's what you're doing here. And then finally, a comment. Comment. I cannot stress it enough. No one has ever complained, you know what, there's just too many comments in this logic. It's usually the opposite, right? Or it's in a different language. Any questions on any of these columns before we break for lunch? All right, make sure you save your project. And then do we want to take the full hour for lunch? Is that what we have scheduled?
That's what's scheduled.
Okay.
Yeah,
Works
let's
for
do
me.
it.
Works for me. So I'll start a 1-hour timer here. I don't have one.
Get a 15-minute warning if you start now.
Yeah, true. Let's add a new timer. All right, so I'll start a 1-hour timer and see you guys after lunch.
Sounds great, Ron. Thank you.
Thank y'all.
Thank you.